This video will be a bit of an oversimplification, but this is going to be the basics of how to swap an electrical outlet. Before you can swap the outlet, you have to know what the circuit that the outlet is going on is rated for. The easiest way to do that is check the electrical panel or circuit breaker box in your house and then figure out which circuit corresponds to the outlet circuit that you're changing. There will be a number printed on the front of the circuit breaker, and that will be the amperage rating of that circuit, and I'm going to show how to figure that out right now. This is my electrical box. Other boxes are typically similar in appearance. They might be a little bit different size-wise, and that's basically going to depend on the size of the house that you're in and how recently the system was updated. So going in here and opening up this box, and I'll try to block as little light as possible. All of these are your individual circuit breakers. Each one of these has a single circuit that goes off and then comes back into it. You can see these different numbers here. You got some 15s, some 20s. Up here we got a 30. That's how much amperage or how much power you can run through the circuit. And basically what these do is they detect if there's too much power going through a circuit. What happens is everything on the circuit's only rated for that much, including the wires. If you have too much power going through it, it's more than the wires can handle, so as a result they heat up and they cause a fire hazard. So most houses will have something like this that has a list of which circuit goes to what in the house. If you don't, you're pretty much going to have someone stand in the room with the light on, and then you hit these until you figure out which one shuts it off. Once you do find the correct one to switch off the room that you want to work on, you look at the little number on the circuit breaker and see if it's the 15, the 20, or the 30, and that'll determine what amperage you need your outlets to be rated. Now that you know what that rating is, you have to get an outlet that's rated for at least as much as your circuit is. So in this case, this one here is a 15 amp 125 volt rating, and then this is a GFI outlet. It's printed on the side instead of on the face. This one is a 20 amp 125 volt rated outlet. The outlet rating has to exceed the circuit rating, otherwise there is a chance you will run too much power through the outlet and it will heat up and potentially cause a fire. Once you have the correct outlet, you need to have a junction box and a faceplate that will match the outlet you're using. These are a couple examples of metal junction boxes. These are mostly used in settings like a garage or in the basement overhead rafters. Most junction boxes in walls are plastic nowadays. You can typically get a couple different depth sizes or a couple different shapes. I got a few shown here, but basically what's going to drive it is what faceplates are available based on the outlet you're using. For example, this is a standard 3-prong outlet. This faceplate matches up perfectly with it. However, this is obviously for a round junction box. Round junction boxes do not have any faceplates with square cutouts that'll accommodate a GFI outlet that I'm aware of. For the most part, if you are replacing an electrical outlet in a house or in a garage that's already existing, there should already be a junction box in place, and as long as you can get a correct faceplate, you should be able to reuse the same junction box. Once you know the junction boxes that you'll be using, what you can do is put the holes in the side for either the power going in or the leads going out to additional outlets. What I'll be doing is having all the lights in my garage on one series of outlets, so all the outlets are going to be connected. If you're doing something like I am where you're connecting multiple outlets, you're going to have 2 holes, one for the lead going in and then another for the lead that's going to go out to your additional outlets in the series. As you can see here, this junction box already has the holes, but most junction boxes come like this, where you can see that's kind of got the tabs in it already, but they're not already removed. Use a screwdriver, pliers, whatever you need to do, and these are only connected on one part, so they'll fold out very easily. You'll wiggle them back and forth a few times and they will break off. You can see here, these ones have cable clamps built into it. If you have a box like this that doesn't have them, the cable clamps you can buy separately and then put onto the edge. The cable clamp does exactly what it sounds like. When you have your lead that goes through the hole in the outside, it sits in here, and then you have the screw in the center. You just tighten that down all the way, and then it clamps the cable into place so that the cable doesn't shake out. Once that lead is through and it's secured, you're going to have your outlet itself get wired. Every outlet, GFI or standard 3-prong, is going to have 2 sets of connectors on each side. When looking at it in the orientation as shown, the 2 tops are going to be for your line in and the 2 bottoms are going to be for your line out to the next outlet. On the right side as shown for both of these, those connectors are brass. I don't know how well it's going to show up, but that's going to be for your black line. Both the inlet line that's black and your outlet line to the next outlet, that's going to go on the brass side. Going over to the other side, again, I'm not sure this is going to show up great on the video, but this is more of a nickel silver color. That's going to be for your white line. The line that's coming in off of your switch or the power source is going to go in to these top 2 as shown again, and then if you want another outlet in line with it, you're going to go from these bottom two to the top two on the next one. I'm going to show this in a diagram real quick to make it a little bit easier to understand. Again, this is a bit of an oversimplification, but you have your electrical circuit panel, and that is going to have all the individual circuit breakers. Once you figure out which one goes to the outlets you're trying to change, read the number on the front, that's the rating. The power line that you have is going to go from the electrical panel down to your outlet, and it's usually going to have all the wires wrapped together in a single sheathing. Once that sheathing gets into the junction box, that it goes through the side hole and is clamped into place, basically you're seeing here, it's going to have these two split offs. You're going to have your white wire that's going to go to the left side when the ground is facing down, and the black wire is going to go to the right side, which is going to be the brass colored screws. If you have multiple outlets in a row, which is what I'm doing because I want all my lights to turn on with one switch, lines on the bottom two connectors are going to go down off of the second prong on the one side of the first down to the top prong on the one side of your second outlet. And it's the same thing going from the second to third. The other side with the white wires is the same thing. The second or bottom one with the ground facing down goes to the top one on the next one. The bottom one on the second one goes to the top of the third, and so on. When you get to the end of your circuit and you have the last outlet on your circuit, these two bottom ones are just going to be unused. Just leave them completely disconnected and don't worry about them. What about the ground wire, you ask? That is an excellent question. I'm so glad you brought it up. So the ground wire itself, this is the symbol, it kind of looks like an upside down tree. That is literally connected to the ground. Usually the ground wire goes to a stake that's driven into the ground, or alternatively, sometimes in older houses, it's wrapped around the main water inlet pipe. That pipe goes down to the ground, and typically the inlet pipes for water are copper, which conducts very well. Ground wire goes up and into your first junction box here, tee off of your main ground wire. One of the leads is going to go here to the junction box itself. What you can do is either use a fastener, like a small nut and bolt, to clamp it onto there, or you can use one of the screws that's holding it into your stud in the rafter or wherever, and use that to connect it. The other tee off is going to go onto your outlet. Looking at our actual outlets here with the GFI and also with our standard 3-prong outlet going down, you see the ground prong is on the bottom. There is your green ground screw. Again, I'll try to get some of that color. That's going to be about the same location on both. So it's going to, once again, come into the junction box, and once you're in the junction box, you're going to tee off. One is going to connect here to the junction box itself, and the other one's going to connect to that green prong on your outlet. After the first outlet, it just continues to go, and then you do the same thing on the second outlet. Tee off, you grab the second junction box, and you grab the second outlet. Every outlet after that's going to be pretty much the same thing. It's just going to keep going, and then you tee off to the outlet in the junction box, and you do that all the way until the end of your series. Connecting the actual wires once they're in the junction box and you're trying to get the outlet in, you just back out these screws on the side a little bit. Wire that's going in will typically have a small exposed end that you're connecting it to the outlet on. What I'll do is I'll take that exposed end and I'll just try to hook it around so it's a little bit of a U shape. Then what you can do is literally hook it over the connection that you're going to and then tighten it down with a screwdriver. Once you've done that on both your supply leads and the leads going out to additional outlets and your ground, what you can do is put on the faceplate and then install the rest of it into the junction box. So the faceplate is just going to be a single center screw. Once you snug that down, it's going to go into here and flush that up to the face. Once you have the faceplate installed, basically there's two types of faceplates. You're either going to have one like this where it's notched in the corners, so you just slide it on like that and then tighten down your screws. The other type of faceplate is going to be like this. I've seen these a lot more. This has one side that's notched and the other side has a hole and then a slight bar coming off of that. So basically you slide the one side with the slot first, you put the screw through the other side and you just rotate it into place. Then you just tighten it down on both sides. These faceplates are obviously not for outlets. Any exposed electrical connection is supposed to be within a junction box, and that's what these faceplates are meant for. If you are not connecting a ground on either type of outlet, most places have a code that requires that somewhere on the outlet face you mark ground is not connected. Rules and regulations for ground connections and connecting to the junction box vary slightly by location, so always check your local laws and your local code before doing any of those connections. Now that we've covered the basic concept of how to do it, I'm going to have an actual installation video of one of the outlets in the garage. I'm going to have a link to that video in the description below. In the meantime, that's going to wrap up this video. Thanks for watching.